Okay, hello again, and I am going to expand on the Xilinx Zinc 7000 series. I guess I'm doing now. So I've got Ethernet working on this MicroPhase dev board. It was a little more tricky than I thought it would be. I'll pull up my thing here. Z7 lite or whatever. Ethernet works great. So it's got an Ethernet, obviously. Um, it is, they say GigaEth, but it is 10 to 100 only. For the PHY, it's a RTL 8021F, which seemed to be pretty easy to work with. I found this compact string just somewhere, just rip grabbing Linux source code. And then device type Ethernet PHY. Obviously, I put my PHY at 40E00. That's just because of what Vivado came with. I did have to enable. Let me rebuild this so I'll stop printing out the interrupts every time. Anyways, I did have to enable FPGA loading on boot, obviously. So I go into the Vivado side of it. So on the Vivado side, I've got pretty simple block, an Axie Ethernet Lite. Really easy to configure. I did set this to 100. Apparently it's not supposed to be 100. Somewhere I heard that that's always 100. And I changed it to 100, but it's 50. So, okay. Yeah. So I had to go in. I had to hook it up in the file. Don't complain at me. These, you have to hook up the pins and your pin constraints and whatever, and you basically just take and copy and paste. For these weird pins, I don't know what to do with these. I just pull them down. I looked up in the data sheet, and most of these are just dumb things. For instance, CRS is carrier or carrier something, carrier detect signal, and then call. The call signal is collisions. I don't know if that's the thing in Ethernet anymore, since it's 2026 and most network switches aren't actual switches, and they route packets instead of just sending the same packet on all the ports. RX error, receive error. I mean, how could it ever fail? It's only Ethernet. How hard could it be? So I don't care about those, mainly because this block does not have inputs for those. Oh, it actually does have inputs for that, but has inputs for the RX error. MDIO, you need the MDIO hooked up. If that's not hooked up, it ain't gonna work. So, cool. What else? I'll show you my implemented design. I mean, it's used however much of the chip that is. I did have to go in and add this. I don't know what this does. It told me not to do it, but everybody on the internet says to do this, so I done it. I think it's because in here these guys and these guys are not in the same thingamajig, so it does not like that apparently. I don't know how to fix that properly, but the internet says just to do this, and it's only 100 megabit Ethernet, so it's not even fast Ethernet. I mean, what could go wrong? I'll show you the Ethernet's working. I'm gonna plug this card in, reset the doodad. It boots up. I'll show you how I'm loading the FPGA. Yeah. So I have an init script. Pretty straightforward. I didn't use the FPGA util garbage. I don't know why anyone would use that. I mean, it's like 3 commands to load the FPGA. I don't know why you use FPGA util, but apparently people use that, so cool, I guess. And then I just use like the FPGA manager driver to load the FPGA. So you just give it like a firmware name and you tell it you're good to go and it just loads it. So easy peasy. For my MAC address, I got this from like the Xilinx example. I don't know, seems to work. It's booting up with DHCP. And it pings. I haven't actually done a speed test, so who knows how this is going to go. But yeah, it's approximately 100 megabit per second. I don't know why it's like 90. That's kind of wonky. It could also be because my Axie bus is only like 50 megahertz. I mean, now that I think about it, how on earth does it do 80 megabit per second on like a 50 megahertz? Oh, well, I guess it's 32-bit wide. So, I mean, that's technically like 200 megabytes a second, I guess. I don't know how Axie works, so I don't know how the bandwidth on that works. But as you can see, it's kind of crap. Not very happy with the Ethernet of this board. It sucks, to be quite frank. But yeah. As for like debugging proc interrupts, you can see there's like, holy crap, 11,115,012 interrupts. Normally, I think when you're doing this professionally or whatever, you use like Xilinx system device tree. I cloned it, but I haven't actually used it because I don't want to be bothered. Like, I pulled the XSA and like, I'm not going to fight all that. I'm just going to hand roll it. So one thing to note, if you're hand rolling the device tree, for whatever reason, this ARM GIC interrupt controller, so like in Vivado, right, go into here. Oh my god, that always annoys the crap out of me. So ID is like 68 to 61, so that's like 7 bits, and then 91 to 84 for the other 8 bits. Or 9 bits, I guess. Anyways, so like there's 16 bits of interrupts, so cool. You get all those interrupts, and like it's on interrupt 61. I have not played around with these. I feel like I shouldn't. I did hook the interrupt to PL key 1 initially when testing, and I determined that the interrupt worked because it would lock up whenever I wasn't pushing the button. So don't do that. Anyways, but yeah, you just need to take the interrupt number and subtract 32, because I think like the first 32 are like system interrupts or something, according to like the driver source code. So you just need to subtract by 32. And then so it's a 3-cell interrupt controller, which is kind of unusual. I think the standard is, what is this? Yeah, Xilinx interrupt controller. Where's like the GIC interrupt controller? I thought I had this pulled up on your time. Oh, yeah, this is another useful tool. I don't want to be bothered being like, going through the trouble of using like Vivado to create the BIM file. So I found this, and it's like a really simple, like 300 lines of C, and it just creates a BIM file from your bit file. And you don't have to deal with bootgen and all that stuff. You don't have to destroy your like compile times, and like your stuff compiles faster. It's just so much better, so much less complicated. And I put that as a package. So like just a build root package, real simple, and I have that as part of like the like install FPGA script. So I run zinc boot BIM, take my FPGA bit file, plop out a BIM file, and I copy the BIM file to the lib firmware directory. And that's like a post fake root thing, so, you know, it just runs when fake root runs. So, can't beat that. Simple. But I'll get back to the Axie interrupt controller thing. Or the interrupt controller thing. Do I maybe have it open? Oh, I do have it open up. I don't know why I do this. I don't just... They all need to be in the same time. So, you want to be using, like, this ARM GIC interrupt controller. I initially tried using, the, Xilinx interrupt controller IP, but, I mean, there's, like, 16 bits, and might as well just use... like, that's plenty. So, I'm going to use this ARM GIC one. This is like the main processor interrupt controller. It is a 3-cell interrupt controller, which is a little weird. Apparently, only 1 and 2 cell interrupt controllers are like normal. I got that from the Linux documentation somewhere. Linux, I'll just Google it. Yeah, right here, I think it was. Yeah, so like this document is like, okay, well, you've got 1 cell interrupt controllers or 2 cells, but they don't talk about 3 cells. So that's something special with this ARM GIC driver, apparently. Anyways, these guys are really important. This 3rd cell is probably the most important. You want to use like low to high interrupts for that Xilinx Ethernet Lite thing. And I got that from just reading the like IP document on this dude. And yeah, I suppose that's probably good enough. But yeah, you'll want to use like 3 cell interrupts. The 2nd cell is the interrupt number. You have to remember you have to subtract 32 here. And then the 1st cell is 0 for SPI and 1 for PPI. I don't know what the hell the difference is. So I just used SPI. Because SPI goes from like 0 to 987 and PPI goes to like 0 to 15. So I assume PPI are really important ones for the CPU or something. So I'm not going to use those. But yeah, you want to do like interrupt state 1 with a SPI type interrupt. And that seems to work pretty well. So yeah, I mean, that's Ethernet on MicroPhase Z7 Lite, I guess. That's the end of this.